Hello friends, welcome to aimstoday YouTube channel. Here we are going to see about IIT NEET Foundation Chemistry in that Atomic Structure Chapter Part 3. In this we are going to discuss about the atomic models which were proposed by different scientists in different era. First of all, what is an atomic model? An atomic model represents how an atom could look like. It may not be a true picture of the exact structure of the atom. It might be just a proposal or as an assumption. Models are often simplified. For example, the small toy cars that you might have played are models. They give you a good idea about a real car, how it looks like. But they are much smaller and much simpler. First, let us say about Dalton's model of the atom. John Dalton proposed that all matter is composed of very small particles called atoms. Of course, this was not a completely new concept, as ancient Greeks proposed that all matter is composed of small individual objects. One more point also to be noted here: when Dalton proposed his model, electrons and nucleus were unknown. Next, Thomson's model of the atom. In 1904, J. Thomson proposed his famous plum pudding model, which is also known as watermelon model. According to him, an atom consists of a positively charged sphere with electrons embedded in it. An atom as a whole is electrically neutral because the negative and positive charges are in equal magnitude. Thomson's atomic model is compared to a watermelon, where he considered the watermelon seeds as negatively charged particles and the red part of the watermelon as the positive charged mass. Rutherfords all for a scattering experiment. Rutherford performed an experiment to give the model of the atom. That is Rutherford's all for a scattering experiment. Rutherford, he was a student of J. Thomson. He modified the atomic structure with the discovery of nucleus. His atomic model is based on the all-for-a scattering experiment. In this experiment, he chosen a thin gold foil to pass alpha particles through it, and to observe what is happening around it, he kept a zinc sulfide screen. He passed a beam of alpha particles through the thin gold foil to observe the atom and noted how the alpha particles are scattering through the gold foil. The important observations done by him are: the first one, most of the rays just went through the gold foil, making scintillations on the zinc sulfide screen. A few rays got deflected or reflected after hitting the gold foil. 1 out of 1000 rays got reflected by an angle 180. That means they are reflected back exactly after hitting the gold foil. So here most of the particles are being passed through the gold foil. Very few are reflected after hitting the gold foil, and very rarely, very few means it is mentioned here 1 out of 1000 got back to their path after hitting the gold foil. From these, he concluded a model of the atom. From his observations, he given an idea about the atom. His new model described the atom as a tiny, dense, positively charged core called a nucleus, surrounded by lighter, negatively charged electrons. This way, the total mass of the atom is constant in the center. Around this is called as a nucleus. Around these, electrons are revolving. Another way of thinking about his model was that the atom was seen to be like a mini solar system, where the electrons orbit the nucleus like planets orbiting the sun. That's why this model is also known as planetary model or solar system model. Next, Bohr's model of the atom. There were, however, some problems with the Rutherfords model. For example, it could not explain very interesting observation that atoms only emit light at certain wavelengths or frequencies. To overcome this, Niels Bohr solved this problem by proposing that electrons could only orbit the nucleus in certain special orbits at different energy levels around the nucleus. Electron cloud model. The electron cloud model is widely accepted model of the atom. It retains the concept of the nucleus from the Bohr's and Rutherford models, but introduces a different definition of the motion of the electrons around the nucleus. The moment of electrons around the nucleus in this model is defined by regions where there is a greater probability of finding an electron at any given moment. These regions are associated with the specific energy levels and take on a variety of odd shapes as the energy of the electrons increase. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.